Hi guys, so welcome to episode 4 of the Final Year Project Diaries, right? Um, in this video, we're going to try and figure out how to keep track of the nodes whenever there are connections being made, right? So in a previous episode, we looked at the code that I have already, which is here, but then we want to be able to keep track of the nodes, whenever a connection is made between two terminals, you want to make sure that you know whether this is node 1, node 2 or something like we should keep track of the nodes, right? So going back into my architecture over here, the keeping track of the node aspect of things like the data, gathering the data from the circuit is not part of the GUI itself, but rather part of the middleware that we are talking about. So the middleware is going to be like node objects and circuit objects, right? And then this stuff would be sent to the simulation backend where maybe a simulation object would be created, and then it would be used to actually do the simulation. But then let's not get ahead of ourselves, right? I know we are not done with the GUI, right? Like there are two more components we need to create: the ground and then the source components, right? But then I feel like since we're already doing connections in the first place, why don't we just go ahead and then start something with the middleware, so that when we are sort of done with that or have something going, then we come back to the components and add the source component and the ground component. What do you guys think? Yeah, so for that part, the middleware aspect, I'm looking at two objects at the moment. I'm looking at a node object, so I'm going to create, we do it already. So a node object, maybe it's too big, make it smaller and zoom in. Yeah, I'm looking at a node object, so there's a normal class, right, in Python, and this node object is supposed to have a few things, right? For a node to be identified, I think it just needs a label and connections to that particular node. So I am looking at a unique ID, and then I'm also looking at components terminals. So this component terminals would be just like how I write any other component terminals, right? So it'd be like a tuple of the component ID, or should I say component? Oh, let me write this under it. So it's be a tuple of what? Component unique ID and the terminal index of that particular component, right? I don't think there is anything extra that we need to do about this, right? Because think about it, there isn't anything extra, right? So a node object is supposed to have a unique identifier and then a components terminals. So this will be sort of a list of the components that you have. So a list of tuples, all the components connected to that particular node. I think that's all that this is all this is about. And then you see, since we'll be having this, I am guessing that we'll have something like a circuit object also. I've not decided what the use for this at the moment, but then I think it would be nice, it would be sensible to have a circuit object, right? So this would also be a class, right? And then it would have two things, right? Obviously the unique ID is very important, so that we'll be able to uniquely identify them, right? And then after the unique ID, I think the only thing that actually makes up circuit is the nodes in the circuit and the components in the circuit. So it would have nodes, which is basically going to be a list or a collection of these nodes at the top there. So a collection of node objects, right? And then it's also going to have the components available. The component, on the other hand, I am thinking it should be like a dictionary of the component ID mapping to, unique IDs of the components, right? Mapping to the components themselves. What do you guys think? So this stuff is what I would say is actually making up like our middleware. It's not anything fancy, it's just like store data and information about the circuit that's being built by the user, right? So like after stuff are done on the canvas, so like whenever a wire is created right here, remember we are drawing a wire, right? So whenever a wire is created, let me add that here. Draw wire. So whenever this draw wire function is called, we will basically draw the wire, right? Draw the wire for it to show, and then also updates the nodes to make sure that we are keeping track of like the changes in the nodes, right? So that's what we are going to be doing. So I think I can bring this like somewhere around here, and I think I should actually be like covering this in some sort of circle or something, because it's looking like everything is just scattered. Right. In any case, there is supposed to be like a connection between this one, the drawing of wire, and oops, I have to do that. There needs to be like a connection between the drawing of wire and the creation of nodes. So you could either be create or update nodes, right? Oops. So create or update nodes. I think let's start coding it, and then maybe if there's anything else we'll add it. So right now what I'm thinking is that for our canvas, for us to even start, I need to actually create the classes, right? I have no idea how to call them, like the group, because you see I have components, main window, and then utils, right? I don't know if I should call a package the middleware, or I should like add it to the simulation backend. I don't know if like it should be like that, But in any case, I think I'm just going to add everything to the simulation backend. So I'm creating a module called simulation backend. I hope everything is spelled well. Obviously, the normal lambda init.py, and then inside this I'm going to create, I don't know if I should create like a middleware. Yeah, why not? So I'm going to create like a new directory in here called middleware, and this one too would be like a sub package or something of the sort, and also having the lambda init.py file. Guys, sorry if my voice is very low. It's like almost 1 a.m. here, and I don't want to disturb like the squad around me. You know what I'm saying? So excuse me if my voice is very low. And oh yeah, I'm supposed to increase the size of this so that you guys will be able to see very well. So let me close some of these stuff because I don't think they're necessary right now. Right now, what we need is the canvas and the middleware. So I'm going to open up, I'm going to create a new file inside the middleware, and I'm going to call that the node. Yeah. Node.py. Or should I call it circuit node? I can't believe I'm actually contemplating whether to call it circuit node or node. Wow. Paul. Node, circuit node, node, circuit node. But whichever one it is, I'm going to basically create like the node class over here, right? So class node, right? And it's going to have to define lambda in it, right? And looking at the architecture here, we said that the node object is supposed to have a unique ID and then the component terminals. So I'm basically just going to define that in here. So the unique ID should be generated from, should I say, the node number and the, so like there would be like a node count that would be passed in here, right? And that node count is supposed to like allow me to generate the unique ID, right? So I don't know if I should have a name here also. So like it's basically like going to be a string, right? And I don't think this type is even necessary. Anyway, node, circuit node or something. One of these is I should have like an enum. I should create an enum to like store all of this. Anyway, circuit node, and I'm supposed to take the node count, right? So I'm supposed to create self dot unique ID, and this is supposed to be an F string of the name. Self dot name and dash the count. What else would I've been doing like all of this time, right? I'll get a count, a unique number, because obviously if I'm counting it and sending it, it will be unique. So like I'm setting off it, and I am concatenate that to the node count, right? And then I'm also supposed to have what self dot what component terminals. Is that what I wrote? Yeah, component terminals, right? And this is supposed to be, should I say, an empty list for now. So it's basically just going to be a list of tuples, right? I think I should define a type for it. From typing import list, I think. And import tuple. So it's going to be a list of tuples of a string and an integer. I guess it would, right? I think this is the right type that I'm supposed to have for it. But how do I get that? I don't think it is something that I need to like assign from the get GUI, right? I shouldn't like pass in an initial thing over here, right? Because it could be any number of them. I don't get what I'm trying, and then this would be updated with time. So I am basically just going to be leaving it like this. So after creating a node, then you add the components that are like on that node, right? That's basically like the idea that I'm trying to have over here. And then since you're already doing this, you might as well create the circuit. .py, and a circuit is supposed to be what, a class, right? A circuit class, and that's supposed to also have like a name. I am just going to call it a circuit, and obviously you define the init, and here in order to create a circuit, I would say, obviously we have the unique ID again, so the circuit count would also be there. And then self.unique ID would be equal to like an F string of the name dash circuit count. This should be self.name. And according to this, the circuit is supposed to have what, the nodes, which is basically a list of nodes above, and it's supposed to be like having a dictionary of all the components available. Right, so well, yes, this should work. So like the circuit would have, I think I need to get access to what, so from .node import node. I think it's time for me to rename this to circuit node. I don't know why, but I feel it's better to be called a circuit node. Yes, rename it. And I'm going to also call this circuit node. Importing circuit node from here to the self.nodes to be assigned to a list of circuit nodes, which will be initially empty, from typing import list then there's also our self.what component, which is supposed to be the dictionary right. I don't know how it works. I don't know how they use the thing, but I'm guessing you'd provide like the first part would be the key and the second one would be the value. Yeah. So it's basically a dictionary of what? Strings and components. So general components. Maybe later I would like just take the components data instead of actually taking the whole Qt object. I mean, like that's maybe taking the components data would be better, but for now, you know what, for now let's assume there are no components, right? Let me just assign it to an empty thing. Like I don't know what to actually give you right now, but so this is like what our circuit node is supposed to be, right? I'm just going to import everything in here from the circuit node. Okay, from the circuit import circuit, from the circuit node import circuit node, so that it would be easy to, like, they will just access it through the middle where it'll be like simulation backend dot middleware, and then they will be able to access it. I think that's like easier. I'm saying they, like I'm not the one going to use it. In any case, so I'd have here, just like I have like components and wires over here, I'd have self.nodes. Yeah, or I should rather have self.circuits. So like self.circuits will be equal to a dictionary, right? Which is also supposed to be like unique ID and then the actual circuit, right? You know what? Let's cool down with the circuits. Let me just have self.nodes first. Okay. So now that I have self.nodes, I am basically going to be updating the nodes. And I also need to like import the node. So from simulation backend dot middleware, import circuit node. Instead of self.node, write it self.circuit nodes. Yeah, I know I'm writing Python, but I'm writing camel casing. Yeah, it's weird to me as well. But it's because of the fact that pyqt seems to be using like this kind of format. So I'm basically also following it. I don't want a situation where the generic names from pyqt, I use the camel casing, and then my own labels, I end up using snake casing. It doesn't like look nice for me. So I'm basically just using camel casing for everything. That's why it looks weird. In any case, I have circuit nodes, right? So what I think I should be doing over here is that whenever wire is created, right? Whenever a wire is created, I need to either create or update nodes after drawing a wire. The reason why I'm saying update node is because sometimes you end up making a connection, but then it's not a new node that you have actually created. You are just adding a component to the previous node that was already there. I don't know if you get what I'm trying to say. So you create or update nodes after drawing wire. And how do I do that? I think this print statement should go down up here. I mean, obviously I'll remove it anyway, but then for now, let's be like there. Right, so I could add a print statement here saying what? Creating / updating nodes. So first of all, I basically check if there's no node, if self.circuit nodes. Is there .count? Let me just check length. If the length of self.circuit nodes, right, is 0, is equal to 0, then I should create a node. And I create that by saying what node is, or should I say new circuit node. New circuit node should be equal to what? Circuit node, and I'm supposed to give it a count, right? And that count is supposed to basically be the length of it's supposed to be the length of what? Self.circuit node. And you know what? Instead of doing this, I prefer to do like node count to be equal to length of circuit nodes. So I can just like copy this, paste here, and make sure that node count is node count. Right, so I'm creating a circuit node, and if that's the case, I'm basically just going to like say that what new circuit node dot components terminals would basically just be dot append. I'm going to add the components terminal that's already there, so I could like add the top, like, how do I even say that thing? Wait for a sec, let's check something. Can I actually do something like this? Dot append, and sorry if you can't see what's in my terminal. Oops. So I'm trying to do something like dot append, and I'm trying to pass a list of stuff. So this side is going to be right, an ID and a certain integer, and then an ID and a certain integer. Can I do something like this? I thought it would print it out for me or something. It left me hanging. Wow. Well, you know what? Hello should be equal to empty array, then hello dot append, and then I'll check out hello. So yeah, you can actually, you don't have to like append a single thing. No, it appended the whole list. I didn't want that. What if I was to do this? Then instead of doing it this way, I spread it out. So it only takes one argument at a time. Oh, then I'm supposed to use a for loop then. I was thinking of trying to be clever about it. But anyway, what I'm basically supposed to do is that. So for components terminal in self.component it something terminals, selected terminals. Yeah. For component terminals, selected terminals, I am going to like say that it should do this dot append component terminal, so that at the end, it would basically end up adding that to it, right? And I think after doing this, I can break, not even break, I can return out of this because the node has already been created, right? But if I mean, it would return anyway, so at the end it doesn't really matter, right? Now if the length is not 0, which means that there is actually some content in there, so there are already nodes in there. I need to make sure that these nodes are not actually, like, I need to check to see if the connection that's being made is actually to an existing node already, or I need to actually like create a new what's the name, a new node. And then you get what I'm trying to see. But then how I'm going to do that is to see this. You see, whenever you connect two lines, right? I think I need to be running the app to even show you what I'm talking about, since I'm only talking in the air. Sorry about that anyway. So the thing is that whenever you click on a wire and connect this to this like this, the selected terminals over here would have this part and this part stored before the line is drawn, right? So if they have this terminal and this terminal stored, what I'm basically doing is that I'm adding these two terminals to a new node if there isn't already one. I hope that makes sense, right? Now, assuming that there is another resistor, right? And I now select this part and connect to this part. Now, this new connection that I've made is actually between this resistor and the last resistor at the bottom over here. Now, the first resistor that's part of the connection, the middle resistor, is already part of a node. So if I'm connecting that resistor to another resistor, then I'm basically connecting this new terminal to that node. So how I'm going to do it is that I'm going to check the nodes that are already there, because obviously this would have created a node. Like the first one would have created a node, this one and this one, when I did it first. Now when that node was created, it would have stored that is this terminal and this terminal that are part of that node. So what I'm going to do is that I'm going to check the new connection between this and this and see if any of them is already part of a node. Then it means that whatever new connection I'm making right now is also part of that node. So I'm not going to create a new node. I'm rather going to append the new device, the third device, as a device, as a should I say, I'm rather going to append this device as a new device that is being added to the previous node. I hope you get what I'm trying to say. Like that's what I'm trying to achieve over here. So if it's not none, I'm basically going to go through the nodes that are already there, right? So I just figured out something that I created a circuit node without actually keeping track of it. So like before returning, right, I'm supposed to actually add new node to the dictionary of nodes. So what I'm basically going to do is to say self.circuit nodes, and I'm going to say that what new node dot unique ID and assign that to new circuit node like this, and I'm going to return. Now if that's not the case, what I'm going to do is to say this. So I'm going to get a keys. So for node ID in how am I going to say that thing? Wait, for node ID in self dot circuit nodes dot keys, the keys would be the actual IDs. I'm going to be getting the node. So existing node would be equal to what? Self dot circuit nodes dot get node ID, right? So when I get that existing node, why does it have the type any? Well, because I didn't define a type for it at the top, so I'm going to define a type for it so that it will be easier. It's a dictionary of string, sorry, str not string, of a string and a circuit node. And from typing, I need to import dict. Yeah, these days I end up like importing, like assigning type to things, because I really want to make sure that I know what I'm talking about, so that when I do dot something, like I really understand it. Because sometimes I don't know, since I started using TypeScript, I ended up liking the fact that there should be types, and that's like one thing that's not nice about Python, right? So I'm going to get the existing node, right, and I'm going to say that what I have to find a way of checking to see if the selected terminals, at least one of the selected terminals is already inside the node terminals already. So what I'm going to do is that and not to stress, what I'm going to do is that how do you, should I say, find, checking to see if at least one element of list A belongs to list B. How do you check if the one of the following items belong to a list, right? So there's list 1 and list 2. Or you can convert them into sets and then try and find an intersection. So you find an intersection and then there is actually something, then it means that it belongs to it. Yeah, that makes sense. Alright, so what am I going to do? Is it just me or my cursor, which is supposed to be like a cursor has turned into just a mouse? Or it's just me? Alright, I don't know what was happening there, but it was looking weird in my eyes. Anyway, so existing terminals set is supposed to be a set of existing node dot components terminals, right? And yeah, right, and then new terminal set is supposed to be set of self dot selected terminals. Now I have two sets, and what I'm going to be doing is to find the intersection between the two of them. So intersection is equal to not existing terminals set dot intersection with new terminal set, right? So if intersection dot let me just do length. If intersection dot length if intersection dot length is equal to 0, then it means that I should create a new node, right? And if intersection is equal to 0, then it means that there isn't a node already, so I should create a new node. And it's basically just going to be this, right? So I think I should actually break this down into like a helper function or something. I think that would be better. So that's, yeah. You know what? All of this should actually be updates circuit nodes. And I'll basically call this after here. And then even inside updating circuit nodes, I'm going to define a function and say create new circuit node, right? And this creation of new circuit node is basically just going to take in it's a list of tuples, right? Just to be sure. Yeah. So what I'm going to basically do is to move this yeah, of course, you should also take the component count, or should I say node count. Yeah, it should take self node count and this. So it's going to take the node count, create a new node, and then it's going to go through, instead of going through selected terminal, it's going to go through spelling mistake, components terminals, and it's going to create a new circuit, and then add the components terminal, and yeah. So right here, what I'm supposed to be doing is to be doing self dot create new circuit node, pass in the circuit count, the node count as node count, and the component terminals as self dot selected terminals. And over here to create new node, of course, passing the component count. Sorry, I'm calling it component count. Node count, bro. Yeah, I'm sorry if this video is getting a whole lot boring. This is how it actually is when you don't know what you're doing and you're trying to figure it out the first time. Like, this is how it is like, right? No, so the thing is that this is a for loop, so I need to be very careful over here, right? So if there's already an existing node, like if I get an intersection to be something, I think I need to break, because if there's already an existing node, why would I connect to another node again? So I can just break the for loop here, right? So if there's already an existing node that I'm connected the same thing to, I can just break the for loop here. And right, then there should be an else, like, I mean, there should be like else continue, but then this, I think this would happen regardless, right? So when the for loop is done, wow, because I need to also return from the function. I mean, if the for loop is done and it turns out that there is already an existing node, yeah, there should be an else. So else, if there is actually an intersection, which means that the existing node is actually part of that node, what I need to be doing is to be doing existing node dot append I think if I do it there, it will be sensible, right? I should be updating it inside the dictionary, because I think if I recreate this over here and I make any change, it might not affect that particular one. I'm not so sure on this, but just to be on the safe side, it will be better to be self.circuitNode.get node ID Yeah, the not component terminals. Dot append, and I need to append the other one, the one that is not already part of it. Wow, this is wild. I have to think about this very carefully, right? So I'm sorry this video is getting long, by the way, but I believe it's cool this way. This is how my life coding is supposed to be, trying to like figure out stuff. It's not like I know what I'm even doing in the first place. So I need to like append the component terminal that is not already in the component terminals of the node. Right. So how do I get access to that? How do I get access to that? I might just use the set thing over here. I mean, if that is indeed the intersection, then I could remove the intersection from this. Like if I get access to the value of the intersection, I could remove it from the selected terminals and it will be left with only one. And if it's left with only one, then I can use that one. But you see, the intersection itself would be like inside a set, it won't be just a value. So how do I get access to that? Difference between two sets. I mean, Python, of course. So like what I'm trying to achieve is this. So if I have this is A minus B, right? So I have the full A to be like the selected terminals and then the intersection. So if I remove the intersection, then this is the new thing that I'm adding. Then I'll get access to this and I can add that. Like that's my idea here. So new terminal set is equal to the difference of this and the intersection. So what does this give me? It is a set, all right, but what's the value in it? See, that's a problem. How to access the single value in a set? Python, of course. Why am I forgetting to even add that? No, I don't want to print. It's not the only way you can access it. I know, like you can actually use the positions, the index, because there isn't actually, should I say? Oh. Okay, yeah, I could do something like this. Wow. I'm really like shocked for the code I'm writing. But I mean, you see, this shouldn't happen if it doesn't find it on the first one. I think this somehow. Please let me know. I believe that a for else statement makes sure that if this runs without breaking, it ends up running the else, right? Let me just confirm. For else statement. For loops also have an else clause, which most of us are unfamiliar with. The else clause executes after loop completes normally. Yes. So if the loop completes normally, then it means that there wouldn't be creation of any new node. So this wouldn't break, and then the else one would be created. Like, would end up running. Does that even make sense? Shouldn't I rather do like the opposite if? I'm feeling for the opposite. I feel I'm feeling for it like this. If the length of the intersection, right, is rather not equal to 0, which means that it has intersected with one of them, then I rather do this stuff. Then I rather do this stuff and break. Something like this. So if I'm actually able to get one of them to get like for there to be an intersection, then I do the updating of the thing and I break. Else, if I end up not finding anything, if I end up not finding any node in here which actually like intersects with the node I'm trying to create, then I create a new one. I think this would be better from my understanding of how the for else works, right? The only thing here is that after this has run, I just want to make sure that the nodes are being updated. So I'm going to like print just like just to like print out. I'll actually remove this part later. So print out current state of node. So self print out self dot circuit nodes, and maybe for circuit node in self dot circuit nodes dot values print out the unique ID and also print out the component. The component terminals. And just put an empty print here so that, you know, it would be nice. Wow. Wow. I just wrote a lot of code without actually even trying to make sure that what I'm doing works. But here goes nothing. I think before I do this, I create a print statement here saying what? Circuit nodes. Right, here goes it. Here goes nothing. I mean, that's how they say it. Here goes nothing. So what I'm going to do is to basically add two components here and try and connect them, right? So wire 2 connects this and connect this. Right. So now it says that what? So this is circuit node 0. Oh. Right, I don't need to print out circuit anyway. So this is circuit node 0. I mean, I don't need this. That's what I'm saying. It's looking weird in my eyes, that's why. But let me close this. And let's go here. So I have two components here, right? And if I connect this, click on the wire 2 first. Connect this and this together. It says that what? I only have one circuit node, this circuit node 0, and it has what? Register 0 and register 1, the first terminals of it, right? Now if I try to connect, if I try to maybe connect another component, let me have 3 resistors here to the same node. Let me see what will happen. This same node. So the same node, and you can see that now it has 3 components having that same node. If I have 4 components all connected to same nodes, all those 4 components are still part of what? Node 0. Now immediately I try to connect this resistor to this one. Is it even connected at all? Right. Then I should have 2 nodes, because all of these belong to one node, and then this is actually another node, right? So with this I can figure out the connection between different nodes. I think this works very well. But then you see, I was thinking of how it would be if I were to connect something like this. If I were to connect a wire from here to here, wouldn't that be a short circuit in between? So I don't know if the simulation backend would be able to interpret the short circuit reference to where the source is at. But I think that being able to keep track of the nodes right now, according to this, there are only 2 nodes, right? This register is connected between this and this. This register is connected between this and this. But you see, there is nothing tracking the fact that there is nothing tracking the fact that this resistor is not only between this node and this node. how am I even saying anything? Like the short circuits, there's nothing keeping track of the short circuits, and that's so like some way. I need to like research on this, right? Research on how to keep track of the short circuits. But right now, I'm very like happy with the work that we have done. Like you can see how we are able to like keep track of nodes. It probably needs like some improvements and some code cleaning, but I guess it works. Like theoretically, it works. Because if you go back to our circuits node component, yeah, this is all that we need, right? So our canvas is supposed to handle all of this. Wow. Right, wow. So yeah, I'll go ahead and try and write a few comments for this, right? Dictionary to store circuit nodes based on their unique IDs and add new connection to existing nodes or updates or create new nodes. So when you're creating a new node, you check the count, gets the current number of this is for unique ID, like this, right? Create new node if there isn't any in there already, and then that one basically just return. There is no point. I was trying, there's no point for the rest of the code. Exit out of function. So if nodes or if there are existing nodes, check to see if new connection is part of an existing node. I mean, why not just replace all of this with that? I mean, it doesn't matter. So I basically like get this set, right? So intersection of component terminals of existing nodes and new nodes, of existing node and new connection would tell if node belongs to, it would tell if new connection belongs to an existing node. That's one long comment. So this is what if new connection belongs to an existing node, then you do this. You append the components terminal that is already in the component terminals of the node. That is not already, yeah, not already in there. Break to make sure that else block doesn't run. So the else block run if the else block will run if new connection doesn't belong to an existing node. You basically like create a new node. Function that takes in node count and function that creates a new node and updates the circuit nodes of the canvas from node count and component terminals involved in connection. Huh. Yes, you know what I'm saying. I think I've written a bunch of comments here. So far, it sort of works apart from the short circuits problem, right? So how do we solve the short circuits problem? That's the question right now. Where do I write this? How do we solve this? The short circuit problem. Great, I guess. Yeah, so guys, like, I don't want the video to be very long. I know I've spent a lot of time on this video already, and what I've written, like, the video might seem a whole lot boring for you guys because I mean, I'm not like telling you anything, I'm basically coding and you guys are watching. But I thank you guys for watching if you're able to like watch up to this point. And if you have any contributions to the code that I've written, please definitely let me know. I am going to like commit this code to be on my GitHub, a public repository which you guys would have access to, so you can like check it out and then just let me know. Link to the repository will be in the description. But I guess like this is the end for this episode. In the next episode we'll try and implement the classes, or should I like go back to the GUI and like finish up the components? That's also something that's there. But I want to like finish up the classes so that it'd be way easier, if you get what I'm trying to say. So in this case, thank you guys for watching. I'll see you guys in the next one. Cheers.